everyone, now I am here with my next video of data structure, and this I want to consider about the topic that is stack. Stack is one of the linear data structure in which I want to tell you the arrangement of element one by one, where we are placing each and every element on the top of first element, then we are having next element on the top of first element, then we are having next element on the top of second element. In this way we can have our stack. You all know, when we are placing books, when we are keeping one book on the top of first book, we are keeping second, then third on the top, then fourth on the top, then fifth on the top. One by one we are placing books. We are not keeping in any other order. We are placing books in this order only. We can placing plates in this order only. This order is known as LIFO principle. We are going to talk about LIFO principle in this video. First of all, something about data structure. Data structure, I told you earlier also. Data structure specify the organization of data elements and the organization perform on it. Actually, some sort of operation is performed on that organization. In programming language, it is referred as data types, and we can have so many data types, but in this I'm considering only two, that is linear and non-linear, because these things ISC students have to consider. That's why I'm considering these only. Linear data structure, we are having more, but we have to consider only this much because these three were in our course. And in these three, array, queue, and stack, this in this video I'm considering only stack. And non-linear data structure, I already told you about tree, uploaded one video, separate video for tree. Now I'm moving further with stack. Now see what is going on in front of you all. The placement. Each and every element is placed on the top of next element. This is the structure where we are saying it is a principle, it is based on the principle of LIFO principle. LIFO means last in, first out. Means element what is present in this structure, the first element comes last and the last element comes first. Now see, in this structure we have to study about stack. That's why I'm showing you this structure, and we are going to study about stack. It is a linear data structure, means we are following a sequential order, and it follows LIFO principle, last in, first out. Only one pointer, that is top, is used to insert, that is push element, and for delete we can say it is pop element from stack. Means one side is closed and one side is open. In this way we can insert element from only one end. We can insert it from one end, we can delete it from that end only. The insertion operation is said to be push and the deletion operation is said to be pop. Now what we have to remember, the counting, the first element, second element, third element, in which position we are placing them one by one, that position is said to be top. Means topmost element is going to be shown by a pointer, that is top. In stack we are having top pointer is used to keep a track of topmost element of stack. When stack is empty, top pointer present in -1 when we are dealing with arrays, because in 0th location in an array we are having one element. If we are not having any element in stack, then the location will be -1. If we are dealing with algorithm, that time we can say top pointer should be present in 0th location or null location, and then we are moving further with counting 1, 2, 3, and 4 and so on. Now see, if we are creating an array, then we have to place element one by one. One end is closed, one end is open. See, one end is closed, one end is open. From this end only we have to insert element, we have to delete element. And from here only. And how? See, how we are inserting element. See, by pushing element inside that box and our top pointer comes here. See how it is going on? When you will insert an element, you have to increase the top pointer by 1. Because in 4th location, you have to insert an element inside stack. But when you are dealing with arrays, that 4th location should be present. Then only you are able to insert element at that position. And see how. Firstly, few things you have to keep in mind, that push is an insert operation and push is an operation which is used to insert an element in stack. Both are same thing. And now when we insert an element, top pointer increase by 1, that is top is equals to top plus 1. But what we have to keep in mind, is it an overflow condition or not? Means if you are having a glass and you are filling a water inside it, if you are filling in this way, it's okay. But when the layer comes, after that water start falling down, means overflow condition, means that glass doesn't have that much capacity to hold more water, means overflow condition occurs. The same way you have to keep in mind that whether that array is able to keep an element inside it or not. If, for example, if I am having an array of size 5, means 0, 1, 2, 3, 4. These location we are having a place for an element. But if somebody provide us 6 elements, then we don't have any position for 6th element here. Means we have to show overflow condition. Before inserting it, we have to keep in mind that is overflow condition occurs or not. If not, then we have to insert an element by increasing the top pointer by 1. How we are going to insert? See, firstly we have to increase in pointer with 1 and then we have to insert an element at that position. Means at top position. Means if we are having already element in 3rd location, we are having element and we have to place element in 4th location. Then we have to increase the position first and then we have to insert element in that position. The same way I had written here. Top is equals to top plus 1 and in top position we are going to insert element. And see the next thing, how we are going to create algorithm of push. Means how we are going to have an insert operation in stack. Stack, S-T-A-C-K in capital letter, is a stack with top as stack pointer. I'm taking few things, I'm declaring it what it is. Top is a stack pointer, STA is a stack. A data item is to be pushed into the stack where the capacity of stack is size. Size Variable indicates the capacity of stack. Item indicates data. Top indicates stack pointer and stack indicates it is stack. Now see, we can create an algorithm in this way also. We can write algorithm on top and then push S comma E. We are supposed to have S and E. S is an array of n elements. E holds value of new element. With the help of comment, I'm going to tell you that S is an array of an element and E is having that element what we have to push inside that stack. Then check for overflow condition. First of all, we have to check before inserting an element in a particular location, we have to check whether an overflow condition occur or not. If occurs, how we are going to check? If our top pointer is equals to size, then we have to display stack overflow. How? If we are having a stack containing 4 elements, we are supposed to insert element inside it, but normally top pointer having a location that is 0. When we are having a first element, then top comes here with value 1 and we are going to place element here. Then if we insert again, element comes here when top is in position 2. If I am going to insert again, top comes in the position 3 and we will fill an element here. Then again top pointer increase by 1. We will fill element here. After that we are not supposed to fill any element. Now if we will try to push again, then we have to display stack overflow because stack is having a capacity that is size equals to 4. Means our top pointer is present in 4th location. That's why we have to display stack overflow. I think you are able to understand what I want to communicate with you all. Now, we can write in this way also. If top is greater than equals to n, then n is a size of array. When we are dealing with algorithm, then we have to write equals to n. When we are creating a program, then we have to write top equals to n minus 1 because in array the last location will be 0, 1, 2, 3. When we are having 4 elements, then the last location will be 3. Means we have to write n minus 1, 4 minus 1. When our top pointer is present in 3rd location, we have to stop here. In this way, you have to deal. Algorithm is different and programming is different. That's why few things you have to keep in mind. Then increase top pointer by 1. If this condition doesn't happen, then increase top pointer by 1. How? Top is equals to top plus 1 and then we have to push element. Element is pushed inside stack in the position that is top. How? See, if we are creating algorithm in a program way, then we have to place else. Top is equals to top plus 1. In S, we are storing E element in the top position and then we have to return. Then we are going to close it. Now moving further, when we deal with pop operation. Pop, what type of operation it is? It is used to delete an element from stack. How it is going to delete an element? See, when we delete an element from stack, we are supposed to decrease top pointer by 1. But one thing we have to keep in mind. What we have to keep in mind? That is, we are having an underflow condition. Yes or no? What do you mean by underflow? In whole stack, we are not having a single element. Means whole stack is empty. How we are supposed to take an element from the empty stack? Then we have to write something there. It is underflow condition. That's why keep in mind, when we are not having anything inside a stack, then we have to display underflow condition. If we are having something in stack, then we can delete an element from that stack. How? See, in this way. We can have an element from here. We can pick an element from here and we can decrease the top pointer. See, in this way we can decrease the top pointer. And when we delete an element in an array, firstly, what we have to do, we have to pick an element from that position, and afterwards we have to decrease the top pointer from that position. If we are having an element in fourth location, means if I'm having some element here and I want to delete an element from here, then what I have to do? Firstly, I have to pick element from fourth position, means element I am picking from fourth position, that is top. Here I am keeping that element and afterwards I am going to decrease that top. And then the position of top pointer comes from 4 to 3 and this element will be deleted. In this way we have to move further with the pop operation. One by one we are going to delete an element and the top pointer decrease by 1. Now moving further with the pop algorithm. How we are going to write algorithm? Stack, the same thing I had written, but here something is different, that is, here we are doing some pop operation, means we are deleting some element. Algorithm, pop, we want S, we don't want E here because we are not bringing E here, we are taking E which is already present. We are going to delete that E which is already present inside array. We are not supposed to bring it from the user. That's why I am keeping S only. Now, firstly we have to check underflow condition. How? If top pointer is equals to 0 or null, we have to display stack underflow. The same thing, top is equals to 0, then stack underflow we have to display. Then if something is there, then firstly we have to pick element from that position and then we have to decrease top pointer. Same thing, firstly we have to pick element, then we have to decrease top pointer and then we will return that element back and we will display that that element is deleted. The same way we will end our algorithm. Now, P is the third operation, that is display, or we can say it is traverse. What is this? Actually, algorithm is this algorithm, or we can say this operation we are using to display elements one by one of stack. We are going to create algorithm for that. But how? Firstly, few things we have to keep in mind, that display operation is used to display elements. Yes, it is from top to 0th location. Where we are placing that top, from that top to 0th location, we have to display element one by one. If elements are not present in stack, then we have to display stack as empty. For loop moves from top to 0 and we have to display element one by one. How? In this order. We have to display element. We can decrease element one by one. The position we are going to decrease, and we have to display the element one by one. Firstly, 19 will be displayed, then 88, then 25, then 12, then 5. In this way, we have to display our elements one by one. See, coming towards the question. This question is in front of you. These kinds of questions come in your ISC papers. Is of 5 marks. Always. Section C, second question. Maximum times ISC provides either stack or queue. Maximum times. That's why, see, few things you have to keep in mind. How you are going to deal with stack. Few operations you are having of stack. You have to keep the flow of stack in your mind, and then you have to create a program by keeping each and everything in your mind. And whatever program provides you, the variables, the array, the position, the constructor, everything you have to keep in mind. And you have to apply the concept of stack in this. Sometimes they are not going to inform you either it is stack or queue or maybe circular queue or DQ, anything. Mostly they are going to provide you stack or queue, but they are not indicating you whether it is stack or queue. You have to understand by reading the question. The demand of a question says either it follows last in first out operations, or it follows first in first out operation, or other things. You have to read each and everything properly and frame whatever type of data structure it is. If you are clear it is stack, then go for stack. Now, for you all, I'm reading that question. A bookshelf is designed to store the books in a stack with LIFO operation. Now I'm writing it is stack, it follows LIFO operation. But always in your paper you are not having it. You can have different kinds of questions. Define a class book with the following specifically. Means you have to keep in mind that you have to create a name of a class that is book. The variables you are having, that is name array, contains names of books. Then you have point index as topmost pointer, means in the place of top we have to use point now. Any of the variable they can provide us, and we have to use that variable only. Max is the maximum capacity of bookshelf, means in place of size they are using max. Then we are having methods. Book int cap means now we are having constructor which provides us the capacity of bookshelf, and we have to keep that capacity in max. And we have to initialize point with -1 because we are keeping an array. When we are going to store point equals to 0, it means we are pointing toward the first location. But in starting we have to keep in mind that element is not present in stack and stack is in -1 location. Then next function, that is void del. Del is going to delete book which is entered in last shelf, and we have to display the name of that book. If there is no book, then we have to display the shelf is empty. Void add is going to add name of the book inside the shelf in topmost location. And void display is going to display a book of shelf. And we have to keep in mind that we have to create a class and the functions, and assume that other functions were already created. If we are having some other functions also, maybe assume that it is created, and main functions need not to be written because it is of 5 marks. But I am going to tell you how you can have your main function also. Now see, if I'm having a class book, I'd already declared a class book with the variables already given. The constructor which provides me capacity, I'm going to store capacity already written, point is equals to -1, because in starting array the starting location is 0th location, we are not supposed to point it, that's why we are keeping our topmost pointer here. Then we have to keep in mind that array size is not declared. Now we have to declare it. Means here we are placing the name of array, and then it's going to allocate memory to an array of max size, means the capacity size. Now the function del means it is going to delete the elements. We are having topmost pointer, that is point. If point place in -1 location, it means shelf is empty, and we had all not placed any of the book in shelf. Now what? If it is not -1, it may be 0, 1, 2, any of the number. Then what happened? It means array is having some of the books, either of the positions. Then what? In any of the position we can have maybe here topmost pointer placed. Something is written here, something is written here. It means something is already present in a particular location. Then I want to display that name, and I want to delete that element. That's why I'm decreasing topmost pointer. Firstly, I want to display element. I want to pick element of from topmost position, and then I want to decrease top by -1. That's why I did it in this way. And if I want to add a book, then I'm having a name in V. But firstly, I want to check whether our topmost pointer is in a last location. Size means max is equals to 5. Max equals to 5, and our element is already in topmost location, means I have to check whether the shelf is in already full or not. If it is already full, means 5 minus 1 is 4. Already topmost element placed in stack. Then we have to stop here by writing shelf is full. If it is not, then we have to insert element here. We have to increase top pointer by 1, and then we have to place element in that topmost pointer. That's why I'd written in this way. I'm increasing the position, and then I'm keeping element in that position. See, these are the 3 ways. Here I'm deleting it because we are having del function here. Then we are having add function, and then we have to proceed with display, and then I want to show you how we are going to have our main function. Now see how. I want to create display now. Before displaying, we have to keep in mind whether something is there to display or not. If we don't have anything else in our shelf, then we have to display that our stack is empty. We don't have anything in stack to display, then stack is empty. But now we are having shelf. That's why shelf empty. And if we are having some book, means else we are having some book, then we will display our books one by one. Means I told you the last book will be displayed first. then second last, then third last, then fourth last. That's why from pointer till 0 we are moving I minus minus, means it may be fourth location, point may be in fourth location, and then we are decreasing one by one, means fourth location will be displayed, then third, then second, then first, and then 0th location. One by one we will display our box. And how we are going to create our main function? See, these are the logic which we are placing in our main function. How? Input stream data buffer written, and these lines were the common lines. What I want first of all, that is the capacity of the shelf, and I want to create an array. That's why. And one more thing, from the static function I want to call all non-static function. That's why we have to create object, and from here I'm forwarding the value of size to the constructor so that they can initialize an array for us with the size. They are going to receive that size and they are going to create an array for us. And now what we are going to do? We want one by one the element should be inserted, and I want to show you how the working of stack is going on. See, with the help of do, I'm using do loop because I want to show you the menu working condition. Firstly, I want to execute the whole menu, and afterwards I am going to ask from the user whether they want to continue or not. But firstly, I want to show you what is going on. That's why I'm using do loop. The menu you are having, you can delete the last element, you can insert an element, you can display the list, and you can have your choice. If you are having your choice that is 1, then you can call a delete function. If you are having another choice, then what? If you are having choice number 2, then you can have to insert an element inside it, that is the book title. You can enter the book title and you can send the title to that function, and that function is going to add that book for us. If it is not, and you had provided the case 3, then you want to display the list. The display function is going to display list for us. And if somebody is going to provide other than this menu and any other value, then default will run. And now I'm going to ask whether you want to continue or not. If you want to continue, press yes. If you don't want to continue, press no. Means you can write yes, you can write no. And I'm going to receive in it, and I'm going to check whether they are saying yes or no. If they are saying yes, then I'm going to continue all these things again, and if they are saying no, I'm going to stop here. See, now I want to show you the output. Capacity is 2, and I'm going to provide the menu. The user provides me 2. Then we are going to give the title of the book, means we have to add a book, means the title is ISC Class 12th Computer Science. Then they are going to ask from us that do you want to continue or not? Yes, I want to continue. Then what? If I want to continue, then again the menu will be displayed. What do you want? I want to add again. Then the title comes ISC Class 11th Computer Science. They're going to ask from me whether you want to continue. Yes, I want to continue. Then again menu appears. I told them that yes, I want to insert element again, but the capacity of array is 2, means we are having 0th location and we are having 1 location, we are having capacity 2. Then they have to stop inserting an element, they have to show us that shelf already full means full shelf, yet, or we can say shelf full. Now see what happened. When we insert 2 here, then they are going to ask from us that is title. I'd written APC class 10th computer application. Then they are saying that stack full means our operation going on correctly. Then see again, yes or no, do you want to continue or not? I am saying yes, I want to continue. Then what do you want to do? I want to see all the books what I had placed inside the bookshelf. Here I am placing book of class 12 and here I am placing book of class 11. And I want to see how it is going to be displayed. See, 11th will be displayed first and 12th will be displayed last because it follows stack. And in stack, the last one will be displayed first and the first one will be displayed last. And then I'm going to ask again whether you want to continue or not. And I'm saying yes, I want to continue. Now everything is filled inside the stack. And now what happened? See, in this output, I want to show you if I will continue yes, then what? Again, menu will be displayed in front of us. And I'm saying now I am having a choice that is 1. 1 indicates I want to display element. Means I want to display the last inserted book. That is of 11th. That's why see already written there that the last entered book deleted name APC class 11th computer science. Now they are asking that whether you want to continue. Then I'm saying yes. Then what the value we are having? See, again we are having menu. Then what? See, I'm placing 3 over there. Why 3? I want to see whether the book I had already deleted is present inside that menu or not. Then box contain that value or not. See, that box doesn't contain 11th class book. In our menu, we are having 3 things. And with the help of my menu, I'd already deleted it. And with the help of that menu, I'm displaying that book to show you all that it is deleted in the same manner of stack. Means the 11th one will be deleted. The 12th one is remaining here. Then again, same thing. I'd written choice 1. That again deleted. Then I'm showing that. Yes, I want to again continue. And again I want to delete. Then what happened? It have to show us that shelf empty. The same thing is written here. Then I'm saying that again I want to continue. And I want to display whatever we are having in our array. Then see what I'm getting. Shelf empty. Display operation never works when shelf is empty. In these ways, you can have your stack. And now, if you have any doubt, do consult with me. Otherwise, goodbye and good luck.